This is a joint work with Pablo and Jorge from Chile and Mexico. Next one. So let me introduce it. The 2D, the problem in 2D, the rectilinear convex. And after you cut all these PFI quadrants, you get this. And this rectilinear convex hull is contained in the normal convex hull or a set of points. And then the property is that this oriented dependent, when you change the orientation of the axis, then the area of that is just contained in the area and is smaller than the area of the normal convex hull. So the paper here is trying to compute the rectilinear convex hull in points in 3D. Next slide. For that, then we do the same, but taking the can you change the next? If you the next one, yeah, another one. If you take the octans, then you can define next. Which are the maximal points with respect to the first octant. So a point is maximal if there is not another one which is dominated. The domination is a point is dominated by another one if a point is less than another one if all these coordinates x, y, and z are less than this problem is the maximum. And then instead of the log n, you have a log to the d minus 2 factor. On points by decreasing set coordinate and going of that you are computing because what you first you compute the maximal points and then you can proceed get into this map. Next slide, please. Uh, with an horizontal plane, what you get is just this horizontal, this orthogonal polygon. I showed you here this only for one octant, but you have to do 8 times for each of the 8 octants in 3D, and then for this you can reconstruct, or you can construct, in fact, the rectangle from top to bottom, and then you compute the rectilinear convex hull in n log n time and linear space. Next one, please. Now, next one, please. Now the next one. Sorry. No, next one. Yeah. Next two. Now the question is, what theta, and then this rectilinear convex hull will change because they change the points which are maximum, and then there will change. We can have connected components and everything. So what happened when the so what we need to know, what we need to know, next slide. above him. So let's here, you can see the plane passing through P1, and all the points which are above this plane, the point that can be dominated by that, to one of this. So if you project this on this plane, you get the red points here in the figure. Here there is a wedge, and then this becomes a maximum point. When this becomes this maximum point? Well, in this interval, when you rotate this wedge, you can compute an interval where this point become or will be a maximum point in this rotation. And you do this for all the points. So when you go from top to bottom, the and so we need this for four directions. So suppose that we are saying that, well, these points are going to escape. There's a maximum are going to escape for the vertical orientation. That we have to do this for the vertical top, vertical down, left, right, and left. And becoming next one and next one and next one. So next slide, please. So in order to do that, we are going to use this data structure, a balanced binary tree, which is essentially you put the points that you have at the moment in this balanced tree, and then left of this path, or on the right of this path, the points that are hanging from one of points of this on this path, and then you have to show the points. For example, if we are looking for the vertical orientation, you have to show the points by x coordinate, and then you. Next one slide, please. Yeah. No, before. Well, next one. Okay, it's okay. So next one, yeah. Suppose that, for example, here I given you an can escape after that, and then if when we arrive to the point P6, we have on the left just the points which are form part of a partition. Of the partition are given by the leaves of the tree, and on the right the partition which are.
1 minute, Carlos. 1 minute.
Yeah. It's okay.
We are about where the slot is almost finished. Okay, we should interrupt the talk now, so that we can get back to schedule.
The key is that you have these partitions, and then you can compute the supporting lines, and for this that you can compute this angle. And knowing this angle, then you know, well, the maximal points belong to a determinate interval. Next slide.
Carlos,
next one.
Carlos, I think your time is up.
For my camera. Yeah. Thank you very much.